Okay, question 3, we've got two particles, we're given both of their masses and they're connected by a light inextensible string. It's a smooth plane, so we don't need to worry about friction, and we're told the force is applied to Q and the direction it is in, and then we're going to be asked to find the acceleration that that causes. So let's get that sketched out. So in question 3, so there's my two particles, they're attached by a light inextensible string. I've got particle P and particle Q. P has a mass of 7 kilograms, so that means a weight of 7g. And Q has a mass of 8 kilograms, so a weight of 8g. And obviously that's not 8 grams, that's 8 multiplied by g, which we take to be 9.8 in maths. So the horizontal force of 30 newtons is applied to Q in a direction away from P. So that's going to be in that direction. That's causing the whole body to move with an acceleration of a, and obviously it must be moving to the right. And then this string that's attaching them will have tension, and the values of tension in the string will be equal and opposite. So we've got tension that's pulling P, and then that same tension is what's slowing or what's hindering Q. So first thing they want me to do is find the acceleration, and then we're going to find the tension. So if I model the whole thing as a single body, so it's combining P and Q together, if I use F equals ma, the resultant force to the right is 30 newtons. The total mass is 15 kilograms. So that's the mass of P and the mass of Q combined. And the acceleration is what I'm trying to find. So if I divide through by 15, I get acceleration is 2 meters a second squared. Okay, and then part B asks me to find the tension. So to find the tension, I can either just look at particle P or just look at particle Q. It really doesn't matter. If I was in an exam, I would probably check both just to make sure I definitely got the same answer. I'm just going to look at P, so that's got one less force to worry about, because P has only got the tension that's pulling it along to the right. Okay, and the weight of it isn't going to affect anything because that's working perpendicular to the direction it's moving in, but I'll label it up anyway. So if I do F equals ma just on P, so the only force acting on P is the tension, the mass of P is 7 kilograms, we've just worked out that the acceleration is 2, and obviously every part of that body is moving with an acceleration of 2 meters a second squared, so the tension is 14 newtons.